Good morning, ladies and gentlemen. Today, you are welcome to the 29th lecture of this course. And this course is concerned with random sampling. This week is devoted to the sampling, and in this context, in this lecture, we are going to discuss the random sampling as we have in previous lectures discussed the other kind of sampling, that is non-random sampling. So in this lecture we would concentrate on the probability sampling, which is further also known as random sampling or chance sampling. So whether it is probability sampling or random sampling or chance sampling, it is same. Why it is so named? Because in this design, in this sample design, every item of the universe or population has an equal chance of being included in the sample. So, if we have to study the satisfaction level of students of a university, and there are 50,000 students in the university. So, each and every student of that university becomes the member of the population or universe of this study, and each one of them has an equal chance or opportunity to be included in the sample. So, it is so to say that a lottery method in which individual units are picked up from the whole group, not deliberately by some mechanical process. That is, any member can join this sample, can be included in the sample. Any item of the population can be part of the sample. It is that. Random sampling ensures the law of statistical regularity. What is that? This law states that if on an average the sample chosen is a random one, the sample will have same composition and characteristics as the universe. So, this law is the basic foundation of this random sampling or probability sampling or the chance sampling. The law is very important in the sense that according to the law, if the sample is chosen as at random, the sample will have the same composition and characteristics as the universe. So, this law is the basic foundation of this sampling Random sampling from a finite population refers to that method of sample selection which gives each possible sample combination an equal probability of being picked up, and each item in the entire population to have an equal chance of being included in the sample. So, in brief, the implications of random sampling or simple random sampling are: number one, it gives each element in the population, each member of the population, each item of the population or universe an equal probability of getting into the sample, and all choices are independent of one another. Further, it gives each possible sample combination an equal probability of being chosen. So, we have introduced the simple random sampling or random sampling in a coin-size way, and it is based on the law of statistical regularity and the most crucial aspect on which this kind of sampling is based is the chance, that is the equal chance that each and every element or member or item of the population or universe has an equal opportunity to be included in the sample, and which is selected, which member or item is selected and which is not selected depends totally on chance. So, if an item or a member of the population has been selected in the sample, it is purely on the basis of chance. Or if some member or the item of the population has been left behind, has not been selected, then also it is purely chance. There is no other factor that is associated with the inclusion or exclusion of the member or item from the population to be included in the sample. We must remember that this is the purely based on the chance, equal opportunity to all. So, if suppose there are, say, in a department, there are 200 students, and from whom the opinion is sought to study the level of satisfaction from teaching in their department. So, all of these 200 students have equal chance to be included in the sample. All of them have equal probability of being included in the sample. Whether they are selected or whether they are not selected, it's all matter of chance. And this is why it is said that the sample that we draw from the population on the purely random basis is called the random sampling and carries the sample carries the characteristics of the population. Now we shall be discussing the methods, how it is done. So the first method to draw a sample from a population, that is through the random sampling method, is the lottery method. This method involves 3 steps. What are those steps? First step is constructing the sample frame. What is sample frame? It is the list of the units of the target population, that is a student's list in case of studying the satisfaction level of a student from teaching. Further examples, electoral roll in alphabetical order and numbered accordingly. So that is the sample frame. If we are working on the women's participation in elections in Iran, so all the voters who are women in Iran, they are the members of the sampling frame. The first step is to construct the sample frame. Then what is next step? The next step is to write the numbers listed in the sampling frame on small pieces of paper and placing these papers in some vessel, drum, jar. Numbers have to be written on slips, small slips, and of course they have to be hidden by folding it, and then these all members of the sampling frame, rather their numbers, has to be put in the jar, vessel or drum after writing their numbers. So this was the second step. Third step is mixing all papers well and taking out one piece of paper from the jar. All these papers on which we have written the numbers concerning the sampling frame, members of the sampling frame, that would be put in the jar and mixed very well. Whichever way, whatever is available, it may be manual, most probably it becomes a manual, you mix it. And then what happens? A prestigious person, a person holding any high post, prestigious post, or even a child is requested to pick the papers from the jar. And that way we go on picking up these numbers from the jar, and then as long as the sample is complete or the papers which have already been selected, they are not replaced. This is without replacement. And normally it is not replaced also, because all the sample frame was, all the members who constituted the sample frame were put in the jar. So there is nobody from the sample from left. So we cannot include from outside the sample frame. And if we replace again this, which has these items or members who have been selected, then it means we are giving them a second chance. So what happens? There is no replacement in normal cases. And even if suppose we have to select a sample of say 10 out of the 100, then before the selection, all the members who constitute 100 have an equal chance. So if one is selected, 99 are left. So still all the members who are now over there, they have equal chance, 1 by 99 of getting into the sample. So non-replacement does not create any problem in the random sampling, and rather replacement is a tricky question. So normally in lottery method there is no replacement, and then this way we go on, the researcher's representative or the one who has been selected to draw or pick up or choose the members whose numbers are written on the paper, and of course it is hidden also. Then it will go on selecting the items from the sample frame for the sample until the vacancy in this sample is full. We have selected all the numbers which were required for the sample. So this way we do the simple random sampling, and it has been a very popular method also. Then next is the Tippett's table or random numbers method. Many statisticians have prepared random numbers table. Among them, a popular one is Tippett's table. Tippett prepared a table of random numbers of 1 to 5 digits each. These numbers are available in various forms, sizes and number combinations in the appendix of the text on statistics. We have these things, these informations, including the Tippett's numbers. So generally Tippett's random number tables are used for the purpose of the random sampling. Tippett gave 10,400 four-figure numbers and selected 41,600 digits from the census reports and combined them into fours to give his random numbers, which may be used to obtain a random sample. So this way Mr. Tippett and other develop a sample from the population because they have already developed random numbers from their research. So, how it works? We will illustrate that. Here we have some Tippett numbers. We illustrate this procedure by this example. First of all, we have reproduced the first 30 sets of Tippetts. Now, suppose we are interested in taking a sample of 10 units from a population of 5,000 units, bearing numbers from 3,001 to 8,000. So, what we do? We shall select the 10 such figures from the above random numbers, which are not less than 3,001 and not more than 8,000. So, if we randomly decide to read the table numbers from left to right, here in this table, starting from the first row itself, we obtain the following numbers: 6641, 3992, 7979, 5911, 3170, 5624, 4167, 5356 and 7483. These are the numbers which have been selected through the Tippett's help. So, this way we do make a kind of sample from the help of Tippett's numbers. Do not have to do anything because the statisticians have made from their research a list of random numbers and they have arranged it in such a way that its randomness is sanctified, and this way we use the Tippett's numbers for developing a sample or making a sample from the population. What we discussed up till now was the sampling from finite universe. What we do if the population is infinite? What about the random sampling in context of infinite populations? That also must be discussed, though briefly. It is relatively difficult to explain the concept of random sample from an infinite population. However, a few examples will show the basic characteristics of such a sample. We have taken the example of throwing of the dice. A dice has 6 faces and written there 1 to 6 is inscribed. So, suppose we consider the 20 throws of a fair dice as a sample from hypothetically infinite population, which consists of results of all possible throws of the dice. That is infinite. So, here the population is infinite. If the probability of getting a particular number, say 1 is the same for each throw and 20 throws are all independent, then we can say that sample is random. Probability of getting any number, 1 or 2 or 3 or 4 or 5 or 6 is same for each throw. And if all the 20 throws are independent, then we can say that the sample is random. Similarly, it would be said to be a sampling from an infinite population if you sample with replacement from a finite population, and our sample would be considered as a random sample if in each draw all elements of the population have the same probability of being selected and successive draws happen to be independent. So, of course, it depends upon the size of the sample that we have to make, and if it is that what the we have to be careful that each member of the sample of the each member which has to be included in the sample has an equal chance or opportunity of being included in the sample, and so that way one can also develop a sample from an infinite population. We are giving the various advantages and disadvantages of the random sampling also and other sampling methods also. Of course, we have not discussed the other sampling methods, that is complex sampling methods, but that is going to be the topic of discussion in the next lecture. However, as do we observe from this table that the cost of the simple random sampling is very high, and we can do it either through the lottery or Tippett tables, and it is not very frequently used. What is the advantage? The advantages are that all elements have equal chance of being selected, included in the sample, minimum knowledge of population needed in advance, low sampling error, easy to analyze. However, there are various disadvantages also for the random sampling. What is that? It requires sample frame for selecting sample, does not utilize researchers' knowledge of population, and large errors than stratified sampling, cannot be used for comparing subgroups. These are the disadvantages. Whereas the cost for, say, systematic sampling is moderate, it is moderately used also, and it is simple to use and draw sample, easy to check, mistakes in drawing elements are relatively unimportant. Its disadvantages are that ignores all persons between 2 nth numbers, possibility of over and under representation, not a probability random sampling as each element has no equal chance of selection. We have the stratified sampling, which is cost is very high, and we can have the proportionate stratification and disproportionate stratified sample also. This is moderately used, assures The advantage is that it assures representation of all groups in sample, and second, enables groups comparison. Whereas its disadvantages are requires accurate information on each stratum proportion, requires more effort than simple random sampling, needs larger sample size than simple random sampling, then cluster sampling, its cost is low and used frequently. Advantages are that easy for large population studies, it's flexible, respondents can substitute each other, whereas in disadvantages, it lacks representation, clusters may vary in size and higher sampling errors. Then we have multi-stage sampling and multi-phase sampling. We find that they have also some advantages. So these are a comparative picture of the random and other methods of sampling, other techniques of sampling, which once we go for the practical making of the sample practically, then only we realize which one of these sampling techniques is useful for the problems that is under study. One more thing in this lecture, that we must be aware of what are the sampling and non-sampling errors, because if we are aware of the sampling errors and what are its sources, then we can be careful. And if we do not know what are the sampling and non-sampling errors, where are its sources, then of course we will be tricked into in fact not we will be tricked into the sampling errors or non-sampling errors creeping in our study. So what is that? First, we must be clear about the sampling errors. Sampling errors arise due to the fact that only a part of the population has been used to estimate population parameters and to draw inferences about the population. We have not utilized the whole population for the study, and if we imply the whole population for the study, we do not make a sample, then there is no scope of the sample error. So sample errors are absent in census survey. So as large the sample, as smaller the chances of sampling error, and as small the sample, larger the chances of the sampling error. So these sampling errors can be measured for a given sample design and size. The measurement of sampling error is usually called the precision of the sampling plan. So although we cannot 100% remove the chances of sample error, because of course none of the population is 100% homogeneous, and the sample we draw has to have a little deviation from the total population, because not all the members of the population are 100% similar. If they are so, then there will be no problem. But in practical life, it is not so. So, by increasing the size of sample, we can increase the precision and decrease the sample error, but increasing the size of sample has its own limitations, because large size sample increases the cost of collecting data and also enhances the systematic bias. So, if it was not so, then we would not have gone, the researcher would not have gone for the sample survey. Then the effective way to increase the precision is to usually select a better sampling design which has a smaller sampling error for a given sample size at a given cost. So, what we have to do? We do not have the opportunity to enhance or increase the sample size as much as we can because of various limitations. We can increase this precision, make the sampling error to minimum by selecting a better sample design, so that this results in small sampling error for a given sample size at a given cost. In practice, however, people prefer a less precise design because it is easier to adopt the same, and also because of the fact that systematic bias can be controlled in a better way in such a design. So, the practically comes into picture, and then we have to be practical. However, one must be aware of the sampling error and how it has to be controlled. The non-sampling errors. The non-sampling errors arise at the stage of collection and preparation of data, and thus they are present in both the sample survey as well as the census survey, because it arises at the stage of collection and preparation of data. So, whether it is sampling or whether it is population study, census survey or sample survey, in both of them this non-sampling errors occurs. The data obtained in census survey is free from sampling errors, however subjected to non-sampling errors. We have already discussed that as the sample size becomes large, the sample error becomes lower, and if there is no sample and the study is on the total population, that is sampling frame includes all the population, then of course there will be no sampling error, but then non-sampling error is everywhere, whether it is census survey or whether it is the sample survey, because it comes in the stage of collection and preparation of data. Finally, the non-sampling errors can be reduced by defining the sampling units, frame and the population correctly, and by employing efficient people in the investigation, and by proper training of the staff, all staff members who have been hired to implement the project. I wish I have been able to clear to you the concept of random sampling and the concept of sampling and non-sampling errors. Thank you very much.